Hello, friends. Have you ever had that strange feeling? That feeling that time seems to be speeding up? Not just on the calendar, but inside your own body? Maybe it's a new ache that wasn't there last year, or just feeling a bit more tired than you used to. We've always been told this is just getting older. A natural, unavoidable process. But what if I told you there's a new suspect in this story? A mysterious, invisible character that has only been around for a few decades, but is now found in every corner of our planet and even inside of us. Today, we're going to investigate a fascinating and slightly unsettling mystery, the potential connection between microplastics and the speed at which we age. Now, before we dive in, crucial reminder, the information in this video is for educational purposes only and does not constitute medical advice. Please, always consult with a qualified healthcare professional for any health concerns, or before making any changes to your health regimen. Our goal here is to explore the science, not to prescribe solutions. All right, let's start with our first clue. It sounds like something out of a horror movie, but it's a real biological phenomenon: zombie cells. In the world of aging research, these are officially called senescent cells. Normally, when our cells get old or damaged, they have two options: repair themselves or die off peacefully in a process called apoptosis. This is healthy. It's like tidying up the house. But some cells, they don't. They enter this zombie-like state. They stop dividing, but they refuse to die. And worse, they start secreting a cocktail of inflammatory signals that can damage the healthy cells around them. For a long time, scientists have known that the number of these zombie cells increases as we get older, and they're linked to many age-related conditions. The question has always been, what causes more of them to appear? This is where our mystery suspect enters the scene. Recent studies, including research published in journals like Environmental International, have shown that when human lung cells are exposed to microplastics in a lab setting, it can induce senescence. It's like the physical stress of these tiny plastic particles pushes the cells into this zombie state. It's our first big clue, a direct physical trigger for a known hallmark of aging. Now, this leads us to our second clue, which those zombie cells were already hinting at: chronic inflammation. Think of inflammation as your body's fire department. When you get a cut, the fire department rushes in, creates some redness and swelling, fixes the problem, and then goes home. That's acute inflammation, and it's a good thing. But what happens if the fire alarm is always on, even at a low level? That's chronic inflammation. Your body's defense systems are constantly simmering, never fully at rest. Scientists at places like Harvard have pointed out that this state is a common feature in many age-related diseases. It's like running your car's engine in the red, all day, every day. Eventually, things start to wear out. So how do microplastics fit in? Imagine your immune cells encountering these tiny foreign particles. They don't belong. The immune system, doing its job, might try to attack them. But plastic isn't a bacterium or a virus. It can't be easily broken down, so the immune cells can get stuck in a loop, constantly sending out inflammatory signals. A 2025 study highlighted by the American College of Cardiology found correlations between higher microplastic concentrations in water sources and a higher prevalence of conditions like high blood pressure and diabetes, which are tied to inflammation. It's a compelling piece of evidence suggesting these particles could be fanning the flames of chronic inflammation in our bodies. Okay, let's move to our third clue. This one is a bit more like software than hardware. It's about how our body reads its own instruction manual. This is the world of the epigenetic clock. Inside every cell is your DNA, your genetic blueprint. But what's just as important is the epigenome. Think of it as the software that tells your DNA which genes to turn on and which to turn off. It's like a conductor leading an orchestra. Scientists have discovered that as we age, the patterns on our epigenome change in predictable ways. It's so predictable they can look at these patterns specifically, something called DNA methylation, and estimate your biological age, which might be older or younger than your chronological age. This is your epigenetic clock. It's like your body's true age. So the question is, can anything cause this clock to tick faster? Can anything? Scratch the CD? Research is still in its early stages here, but it's pointing in a fascinating direction. Studies on fish and other organisms have shown that exposure to microplastics can cause changes in DNA methylation patterns. The National Institute of Environmental Health Sciences has highlighted research where microplastic exposure in lab models led to epigenetic silencing. While we need more human studies, this clue suggests that microplastics might not just be a physical irritant. They could be interfering with the very instructions that run our cells, potentially making our biological clock tick a little bit faster. It's a chilling thought, isn't it? That brings us to clue number 4, which is all about energy. Let's talk about the power plants of our cells. Mitochondria. Mitochondria are incredible. They take the food we eat and the air we breathe and turn it into the energy that powers everything you do. But this energy production creates byproducts like a car's exhaust. These are called free radicals, and a certain amount is normal. Our mitochondria have built-in systems to handle them. However, as we age, our mitochondria can become less efficient. They produce less energy and more of that damaging exhaust. This is called mitochondrial dysfunction, and it's a core driver of the aging process. It's like a city's power grid slowly failing. Now, where do our plastic particles come in? When micro and nanoplastics get inside a cell, they can cause what's known as oxidative stress. That's an overproduction of those free radicals. Research published in journals like Chemisphere has shown that microplastics can accumulate in the mitochondria, directly disrupting their function and leading to an increase in this oxidative stress. So, not only might these particles be causing inflammation and confusing our DNA software, they might also be directly attacking our cellular power plants, leaving us with an energy deficit and an excess of cellular damage. This all sounds pretty grim, right? Zombie cells, constant inflammation, a scratched CD, and failing power plants. But this brings us to our final and most important point: hope and a path forward. Science isn't just about identifying problems, it's about finding solutions. The research we've talked about today is at the frontier. Scientists at the Salk Institute study how the body clears out waste. And researchers globally are investigating compounds called senolytics, which are designed to help the body clear out those zombie cells. Others are looking at ways to support mitochondrial health and reduce inflammation. It's crucial to understand that these are experimental ideas, not current treatments for aging. We are not there yet. But the very fact that we are understanding aging on this level is incredibly hopeful. And this research also gives us power in our daily lives. While we can't completely avoid microplastics, credible sources like the CDC and Harvard Medical School suggest that we can take steps to reduce our exposure. Simple things, like filtering our drinking water, avoiding heating food in plastic containers, and choosing natural fibers for clothing when possible, can potentially lower our body's microplastic load. These aren't cures for aging, but they are logical, science-backed steps that may support our body's natural defenses. So, let's recap our investigation. Started with a simple question. Could something in our modern world be accelerating the aging process? We uncovered 5 major clues: the rise of zombie cells, the smoldering fire of chronic inflammation, the scratches on our epigenetic CD, the damage to our cellular power plants, and finally, the path towards solutions being forged by science. The story of microplastics and aging is still being written. We don't have all the answers, but it's a powerful reminder that our health is deeply connected to the health of our environment. The mystery isn't fully solved, but the clues are pointing us toward a future where we might have more control over how we age than we ever thought possible. What are your thoughts on this? Does it change how you see the world around you? Let me know in the comments below. And if you found this journey as fascinating as I did, please like this video and subscribe for more deep dives into the science that's shaping our future. Thanks for watching.